Nuclear Fission and Power Plants by Hugh Healy, August Galina, Ben Carr, Nolan Riley, and Julian Schreindorfer.
Nuclear fission. What is it? Well, according to the U.S. Energy Information Administration, nuclear fission is the process in which a neutron collides with the uranium atom, splitting it, releasing a large amount of energy in the form of heat and radiation. As you can see in the diagram, the nuclear reaction happens in the nuclear core. Heat and radiation are given off where it meets with water, causes steam to build and form, and this steam in turn spins a turbine which generates electricity. Then the excess steam is then condensed and put back into the cool water basin, and the warmer condensed water goes out and into the environment as steam. Now, what are the benefits of nuclear fission? Nuclear fission is a clean energy source. According to the U.S. Department of Energy, there are no greenhouse gases released due to nuclear fission. It is also a high energy output. According to the worldnuclear.org, 1 kilogram of uranium produces about 20,000 times as much energy as 1 kilogram of coal. Now, nuclear energy also creates jobs. According to the U.S. Department of Energy again, about 500,000 jobs are supported by nuclear fission. What are the problems with nuclear fission? Nuclear waste is the leading problem with nuclear energy production, as it can last up to hundreds of thousands of years according to the U.S. Nuclear Regulatory Commission, and it can stay radioactive for these thousands of years. It's very dangerous to humans. Accidents like Fukushima, Japan in 2011 and Chernobyl, Ukraine in 1986 were big. The public was very afraid of these incidents as they killed 30 people when reactors melted down, and another 30 people died later because of radiation complications such as cancers in the body. Now, according to Green America, an organization that promotes environmentally aware, ethical consumerism, there's also high cost to nuclear energy, as these facilities are expensive to build and to maintain.
So what would our first solution be? Our first solution would be to improve the design and planning of these nuclear power plants. According to Rebecca Smith of the Wall Street Journal, these improvements could be simple and similar to how we have been improved on the past iterations of nuclear energy. They don't need to be complex, just simple safety improvements or efficiency improvements. Our first example of this would be the Fukushima Daiichi incident in 2011. Poor planning and design of the reactor and plant led to the disaster known as the Fukushima disaster. It was placed along the coastline of Japan, where there was many tropical disasters and earthquakes. Continued. The nuclear reactor was designed in a way that when it shut down due to an earthquake, it was still producing about 1.5 of its natural energy output, according to the World Nuclear Association. It was not, however, taking out this energy, meaning that it was just accumulating inside of the reactor. The limitations would be that this safety comes at a price, meaning that the safer you make it, the more expensive it would be to maintain. This efficiency decreases the more safer you make it. So there's a negative correlation between how safe you make your power plants and the efficiency of it. If implicated, this might only fix public outlook, because the biggest problem with it, the cost, would still be there. People would see nuclear energy as a much safer and efficient form of energy. However, it would still cost a lot. This cost would start high and then eventually lower out and plateau.
Our second solution to this problem is nuclear reactors with heat sensors. These heat sensors, they would sense a sharp temperature change in convection currents, and according to an HVAC technician named John Castro at the Palo Verde nuclear power plant, he says that operators could take their hands off of the controls and the reactor would automatically shut down due to convection currents and heat sensors in the nuclear reactor. So when it shuts down, It will help mitigate nuclear accidents before they even start, and this will also improve the public outlook, because with less accidents, that means there's going to be a greater approval. We also have the limitations to this problem. First off, it doesn't solve our radioactive waste problem. It's still going to be there, and it's not going to go away until we have a solution to it. We also have a very high upfront cost, like August said. It'll be high, and then it'll dip down and plateau, and then it also may lack accuracy, like everything that humans create. Our implications to this problem: it will improve our safety, and then it will also improve our efficiency because it will decrease our downtime in the nuclear power plant, and then it will save money long run because of the money lost from an accident wouldn't be lost because we stopped the accident before it actually happened.
So our final solution would be re-enrich and reuse spent fuel. John Castro again explains that first, this would decrease the total amount of radioactive waste on our planet. Secondly, this would create long-term economic benefits because we wouldn't have to do as much uranium mining to achieve that uranium. And lastly, this conserves our resources. Since uranium is a finite source, we need to use as much of it as we possibly can. Here's a diagram of the entire nuclear fuel cycle, but we're just going to focus on the reprocessing plant. So as you can see, it's reprocessed into uranium and then into plutonium. That uranium is flung through back the entire cycle again, but then that plutonium, which is the main limitation, is given off as waste. And if you don't already know, plutonium is the main ingredient in nuclear bombs. This could pose a huge threat. If it is targeted, it can create a huge nuclear blast that can destroy the environment around it. Also, this includes high costs. It just may not even be worth it if we can just do more uranium mining rather than re-enriching and reusing that spent fuel if it costs more. Implications would be that it would create a healthier environment, as there would be less radioactive waste on the planet, and it would help save our environment. And lastly, it conserves the amount of uranium that we use. Like I said, uranium is a finite source, and we need to use as much of it as we possibly can.
So what is the best solution? The best solution is to have better designing and planning of nuclear power plants. The better designing and planning of nuclear power plants would allow for them to be protected from natural disasters that are becoming ever more frequent. As a result of this, the public and governments would be more willing to accept nuclear power as the major energy source of the future. The other solution of reprocessing used fuel would not even address this major issue of safety and lack of public support. Heat sensors would be ineffective against natural disasters that are water-based and cold. Now we consider the economic drawbacks of the solutions. Better designing and heat sensors both have high upfront costs that will toll over time. Reprocessing waste have constant high costs. The better designing would really only be construction costs, so money is not really a concern. The better design would minimize uranium used in energy making and also minimizing the nuclear waste that would damage the environment. The safety, economic, and environmental benefits of this solution of better planning and design has led us to believe that it is the best solution.
Okay, thank you guys. I'm going to ask each of you a question now about your project. We're going to start with Julian. Julian, reflecting on your colleagues' work, which one had the greatest impact on your overall understanding of the problem your group identified?
So Ben, he had the environmental lens, and he was talking about all the natural disasters that have affected the nuclear power plants in the past, such as Fukushima. There was big disasters, and this nuclear waste was detrimental to the environment. And also, he talked about the nuclear waste in his paper that we also mentioned in this presentation about the nuclear waste.
Okay, thank you. All right, Nolan, if you had another team member, what other perspective or limitation could they have researched, and what would have made a useful contribution to this project?
So we could have looked at the problem at nuclear energy through a social and cultural lens, as certain demographics are affected by the output of nuclear energy. So this could be looking at towns near nuclear power plants and how most of their energy is from nuclear power plants and what their takes are on nuclear energy, because they're close to it, they understand it, and many of these towns near nuclear power plants, many of the people there have jobs at these plants. So that would be a big lens that we could have looked at and could have incorporated into our study.
Okay, thank you. August,
Yes.
how did the group decide to include Hugh's perspective or conclusion into your presentation?
So Hugh took it from an economical lens, so all the prices, and we talk about cost of these solutions often in our presentation. He kind of showed us what that would mean. So all of our implications and our problems with solutions, or even nuclear energy as well, he was able to supply us with, drawbacks or obstacles. that
Okay,
we faced.
thank you. And Hugh, can you give one specific way that your thinking changed as a result of learning about Ben's findings?
Ben was talking about an environmental lens, and I think my ideas of nuclear energy changed through his environmental concerns, through natural disasters. So I didn't think it was that big of a deal because we only had 2 major accidents. So I thought it changed my idea of what people see about it and what people are going to see about it in the future.
Okay. And finally, Ben, what is a way in which your team's resolution makes you think differently about your own research?
Well, I had a lot of implications and different solutions in my paper, but I would have to say that better design and planning was kind of it was the main reason that we chose it, because it's able to block those nuclear accidents, because like August said, if we place the plant, we place it in Fukushima, we place it on a shoreline in an earthquake-heavy country with tsunamis, it was very poorly planned, and it created huge devastation and allowed 100,000 people that had to be relocated to their houses. So